Okay, any modern intermediate algebra textbook is going to have a section called the Algebra of Functions, where you are asked to algebraically manipulate function notation. Not that tough. I think I can really help you out here, but we need to take an intense look at this problem. So let's see what they're asking us. They're saying we are going to let big F of x equal this, and then we are going to let big G of x equal this. Given those two definitions, they want us to find big F divided by big G with an input of x, and then big F divided by G with a specific real number input of -2. Okay, we certainly can do that, but I want to take a review and preview of these two functions. First off, big F. When you look at the right hand side here, this is what's called a quadratic function because the x on the right hand side is to the second power. We will have a whole chapter dealing with the graphs of these things. They graph as parabolas. That will be the second half of the course. This other function, however, the right hand side, f5 minus x, I'm hoping this rings some bells for you. First off, you remember that you can replace the left hand side, the g of x here, with y. And now what we have here is a linear equation, and I'm hoping you see instantly that this can graph as a line because the criteria for that are met. Namely, we have one or two variables. In this case we have two, and both those variables are to the first power, y to the first power and x to the first power. When you have those two criteria, you have a line. So this is going to graph as a line. Now let's get after the first problem here, and what they ask us to do is put the expression representing f on top, and then put the expression representing g on the bottom, and then input what's ever here, in this case x. So what I'm telling you here is that basically this is a substitution problem, except we're substituting in expressions, and that's what I've done here. For big F, I substituted in the expression x squared minus 2, and for big G I put in its expression 5 minus x. And I'm done it, unless something simplifies, and nothing simplifies here. However, I'm not done. There's an idea that threads this course, and you're going to see it time and time again, and that is this first commandment of mathematics, namely that division by 0 is a no-no. And so if x is ever 5 here, then I'm going to have 5 minus 5 or 0. I need to bookmark the fact that x can never be 5. And so basically what you do is you tell the reader, the grader, that here's the answer, but x can never be 5. And you're done. Now, this is sort of a screwy problem from the student's perspective because we had an input of x and the original problems had all x's. I just want to show you something here really quickly, that this problem could just as easily have said this. The same problem except I'm using a instead of x. And you could think of that as being a and x as being essentially what mathematicians call a dummy variable. They're placeholders. This could really be any particular value here, any letter, and it would be the same problem. Here I've replaced the x with an a, and so to the right hand side, wherever there was an x, I replaced it with an a. Now that would have been a keener problem than the one they gave us because of the fact that we had x's originally and we didn't have to do any work with the input value. Now in the second problem, we're definitely going to have to do some work with the input value. And what it's telling us here is that wherever x appears, you're going to replace it with -2. And I've done that the way I think many of you would do it initially. And that's like that. Wherever x appears, I've replaced it with -2. And what I'm telling you right now is that replacement that I just made is wrong. And you need to practice safe math. You need to enclose your negative values in a protective sheath of parentheses. And so what I suggest is when you make that substitution of -2, what you really want to do is make it look like this. Now, this is really critical because here I see the negative 2 is being squared, and so it is going to come out positive 4. Over here, I don't see that at all. This actually evaluates to negative 4. So by placing the negative 2 in parentheses, I've hugged that minus sign, and I'm practicing safe math. Similarly, down here, I have something interesting happening here, a double negative, which is going to end up as a positive 2. Now really all that's left is to knock out the math, the arithmetic, not make any errors, and then box our answer, which I'm going to do once I select the proper tool, like so. Okay, I hope that helped. Good luck with the algebra of functions.